Einstein's theory assumes that moving matter doesn't affect light. But what if that assumption is wrong? You are watching True Physics. Einstein's 1905 special theory relativity was built on the simple idea that we know that the speed of light is globally constant throughout space, for every observer. This is implemented as Minkowski spacetime, which assumes that moving matter has no effect on a region's light beam geometry. Unfortunately, we know that this idea is wrong. My name is Eric Baird and you are watching True Physics. If we collect many atoms in a transparent substance like glass or water, the speed of light moving through it is slowed. We call this the refractive index. If we make that material move, light travels faster in the direction the atoms are moving. This is the Fizeau-Fresnel effect, verified around 1850. Furthermore, shining light through a spinning transparent disk deflects the beam sideways. As shown by R.V. Jones in 1971, moving matter clearly alters light propagation. What sorts of objects break special relativity? Let's look at 5 examples of particulate media. Number 1. The human eyeball. To focus light, our eyes are filled with watery fluid. A moving eyeball should drag light, breaking Minkowski's geometry. Number 2. The human body. Human skin is translucent, so light entering it gets physically dragged along if the skin is moving. Number 3. Fish, dragonfly wings, and jellyfish. Number 4. The mediums they move through. Moving water and moving air both drag light. Number 5. Polar bears. Their fur is made of transparent, hollow hairs that scatter light, meaning a fast-moving polar bear would also drag light. Number 6. Spaceships and astronauts. A spaceship window is a particulate medium that drags light, and so is the air inside a spacesuit. Number 7. Trains and trams. Moving trains have glass windows and contain air that drags light, disagreeing with standard relativity thought experiments. Number 8. Sand. Even a single grain of transparent quartz sand moving at high speed should drag light. Number 9. Interstellar gas and dust clouds are particulate media, obviously, and galaxies are just bigger dust clouds. Number 10. The Earth and major planets. The region around the orbiting Earth drags light because it has an atmosphere, just like Jupiter, Mars, and Venus. Number 11. Stars. Stars have atmospheres, like the photosphere and corona, meaning moving stars act as particulate media and do not strictly obey special relativity. Number 12. Interstellar space. According to the extinction theorem, even the low matter density of deep space is enough to drag light over vast regions. Number 13. Particle accelerators. A particle beam is by definition a particulate medium. A laser aimed across it in the lab frame ought to be deflected. Number 14. Camera sensors and lenses. Glass or clear acrylic lenses drag light, and the silicon used in electronic sensors drags light as well. Number 15. Black holes. The gravitational horizon of a collapsed star is supposed to drag light completely as it rotates, and similarly if it moves. 16. All other gravitational matter. A moving star creates a Shapiro timelag, which offsets the rate light propagates, creating a drag from lag. 17. Fundamental massed particles. If we get close enough to a particle's curvature horizon, its drag strength is expected to reach 100%. 18. Particles under quantum mechanics. Some argue particles mimic a slower speed by absorbing and re-emitting light, giving a Fizeau-style offset. 19. All real matter. Following the equivalence principle, if gravitational mass drags light, all real matter must inherently do the same. 20. Classical field theory. Even abstract momentum fields interact with light propagation, meaning no physical medium can truly have zero drag. We have 2 main options for how matter drags light. If the surface drag is 0, we get Lorentzian relativity, which Einstein chose in 1905. If the surface drag is 100%, we get Hertzian relativity. Unfortunately, we know the drag cannot be 0 because of physical media like water, glass, sand, stars, and polar bears. This means special relativity must have the wrong basic equations for the motion of matter. As always, if you want more of this material, like and follow True Physics.